Assalamualaikum and good morning. Okay, so this is the continuation from previous lecture, which is voltage divider biasing. But we are going to use this voltage divider biasing in order to design a small signal amplifier. So basically, the operation in voltage divider biasing, same as self-bias, you need to have two types of analysis, which is DC analysis and AC analysis. So if you look at this figure, this is the typical voltage divider amplifier typical circuit. So ini yang normalnya yang kamu lihat lah. Okay, so in this example, the FET used in the amplifier circuit shown in figure 6 has the following parameters: VGS off equal to -5 and the IDSS equal to 10 milliampere. So the typical parameters that you need to find out is what is your punya ID, what is the VGS, and what is your punya VCE. So this is the typical parameters yang kamu mesti cari. So in order to find ID, you require IDSS, you require VGS, and you require VGS off. So based on the question, IDSS is given and VGS off is also given. But VGS is not given, so you need to find what is your punya VGS. So as you know that VG is equal to VGS plus VRS. So you need to calculate what is your punya VG applying voltage divider rule, which is R2 divided by R2 plus R1. And then you multiply dengan your punya source. So you get VGG equal to 2.22 volt. And then VS is also equal to VRS. So VS is equal to IDRS. And then if you manipulate this equation, VGS is equal to VG minus VRS. So you get this equation for VGS, and then you can substitute this equation for VGS equal to this one. So in the end, if you simplify kamu punya equation to this one, you get two drain current, which is ID1 and ID2. From this ID1 and ID2, you need to determine which is the valid ID using this VGS punya equation. So if your VGS is less than VGS off, if the VGS2 less than VGS off, then kamu punya VGS is valid. So the next one you need to calculate is, bukan VCE ya. VCE is BJT. So you need to find you punya VDS. So VDS, if you apply KVL, VDD equal to VRD plus VDS plus VRS. So VDS is equal to VDD minus VRD and VRS. So kamu dapat VDS equal to 6.844 volt. And then you need to calculate kamu punya GM. So this is GM0. So in the end kamu dapat GM, the transconductance, is equal to 2.1168 millisiemens. Bukan seconds, millisiemens namanya. Okay, so that's it untuk kamu cari kamu punya DC value. Sampai sini saja nih, DC analysis. Next, you need to find ia punya voltage gain. Voltage gain is equal to V out divided by V in. In order to calculate this voltage gain, you need to convert this diagram into equivalent circuit. This one, equivalent circuit. So in order to convert the original circuit into equivalent circuit, capacitor will act as short circuit one. Number two, all DC component will be grounded. Okay. So if you look at this one, capacitor this one, ia jadi short in AC analysis. Ia jadi short. This one also short. Okay. Walaupun ada kapasitor di sini, in this circuit, kamu indah payah cari or concern about this capacitor untuk mengacau kamu punya diagram or circuit. The only concern you need to have is for this RS. Since capacitor is short circuit in AC analysis, this RS will be also shorted because of this capacitor. Current will flow to the lowest resistance as possible. So comparing to this one and this one, this has lower resistance. So current will go to here rather than this way. So drawing into your punya equivalent circuit, it becomes like this. So previously, this yang di sini tadi is connected arah kamu punya VDD, arah kamu punya supply plus 20 volt in DC component. Since your punya rule is all DC component will be grounded, so you need to replace this one dengan ground. So this is kamu punya circuit. So previously di sini ada kamu punya RS. Previously you have RS at this point. Since ada capacitor, the RS will be shorted. So ia jadi hilang. So ia jadi straight line saja macam ni. Okay. So in order to get voltage gain, you need to know what is kamu punya V out and what is you punya V in. So if you look at this diagram, kamu punya V out is at this point. Di sini. Di sini kamu punya V out. So if you look at this V out should be equal to the voltage across this point. So V out is equal to any current, dependent current. You can call this one ID RD. So this one, voltage across this point is ID RD. So Vn is at this point. This is kamu punya Vn. So Vn is equal to VGS. Sebenarnya Vn ini sampai ke bawah, sampai ke ground. But since there is no RS, nada RS, so sebab itu di sini Vn is equal to only VGS. So finally, you can combine the equation. AV is equal to V out divided by Vn. So VGS boleh cancel. Sorry ya, bukannya huruf besarnya supposed to be small letter. So Vin equal to VGS. So ini boleh cancel. So yang tinggal AV equal to GM RD. Transconductance kamu sudah dapat cari tadi yang di atas. So AV equal to 6.3504. Itu kamu punya voltage gain. So finish. So let's say for example, okay, so we have finished yang the question, the existing question. So the next question di sini, let's say you have a load resistor. Di mana kena simpan load resistor ni? Load resistor will be kena simpan at this point. Load resistor will be kena simpan di sini. So tadi load resistor is 6 kilo ohm. So what happened to the circuit? What happened to the voltage gain when kamu ada load resistor? So if you draw it into kamu punya equivalent circuit, this is kamu punya load resistor. We call this one RL, which is 6 kilo ohm. So what happened to kamu punya V out, the new V out? So basically, kamu punya V out is still the same, but you need to combine these two resistor. So we can call this one REQ. So ID REQ. REQ is equal to 3 kilo ohm in parallel dengan RL. So that's why di sini you can also call this one REQ. REQ equal to RD equal to RD in parallel sama RL, you get 2 kilo ohm. So AV is equal to GM REQ. So in the end, kamu punya voltage gain is 4.234. So that's what you need to know on how to do an analysis for FET. To summarize, in order to solve any FET punya question, you need to know what is your punya ID, VGS and VDS. So basically, in voltage divider biasing, you need to know what is your punya VG. So you need to apply voltage divider rule. Sudah kamu dapat voltage divider rule, you need to know what is your punya VS ataupun your punya VRS. So you combine the equation, masukkan ke dalam this one. So from this equation, you get 2 ID ID1 and ID2. Then you need to determine which ID and VGS is the valid one. So if you insert or substitute this ID into this equation, you will get 2 VGS. So if the VGS is less than the VGS off, then kamu punya VGS is valid. So next you need to determine what is your punya VDS. And then kamu punya GM, the transconductance. At this point, kamu already solve half of the question, which is your punya DC analysis. Next, you need to solve in AC analysis, where you need to convert the original circuit into this equivalent circuit. The rule in converting the original circuit into equivalent circuit is all capacitor will be short circuit and all the DC component or DC yang connected with DC supply will be grounded. So in this AC equivalent circuit, what you need to apa kamu punya objective is you want to find out what is your punya voltage gain. Voltage gain is equal to V out divided by Vn. So kamu punya, based on this diagram, kamu punya V out is at this point. Depending on kamu punya circuit, ada load resistor or yang nada load resistor. If you have load resistor, you need to tambah lagi satu di sini, jadikan dia RL. But if nada load resistor, you can erase this part. So taruh saja kamu pakai this voltage, kamu punya V out, which is ID 3 kilo ohm. So Vn is equal to VGS. Direct saja VGS because there is no RS di sini. If there is RS di sini, kamu punya Vn will be berubah. Let's say for example, you have RS di sini. For example, so kamu punya Vn is equal to VGS plus VRS. Ini if ada RS di sini. If there is no RS, if RS is short circuit, let's say RS is short circuit, nada. So you can cancel this one, jadi 0. That's why Vin equal to VGS. So substitute the equation. So V out divided by Vn, and then VGS will be cancelled. So AV is equal to GMRV. At this point, you can calculate what is kamu punya voltage gain, which is 6.3504. And then, if you have load resistor in your circuit, you need to jadikannya satu. Combine them. So baru tu kamu cari ia punya voltage gain. So in the end, kamu punya voltage gain is 4.234. So if you compare gain, voltage gain with no load and with load, which one is larger? So if you look at this analysis, you can see that the voltage gain without load is much larger compared to the voltage gain with load. Okay, so that is the end of FET punya analysis. If you have any question, you can ask me. And please do the tutorial since I have given you your punya question and the solution already. Okay. So I wish you all the best. So assalamualaikum and good morning.